Hello, this is Jacob Briggs, and I'm here to talk about our um, the sorting project using our linked list and putting two sorting algorithms into it to show off that we can get that working. So for my two, I just used the same linked list project as earlier and built on it. So I have a section for my sorting code, and I have an insertion sort and a merge sort. So first, we'll talk about and show off insertion sort because I have my merge sort down here commented out so that when we go in, it'll only do insertion sort since I figured out that it was going to be a little weird to show off that both of them worked one after another by showing them both because they sort into the same order. So anyway, starting off with insertion sort, we have a function called sorted insert. Um, and this function will actually insert our nodes into its ordered form. It essentially takes our numbers and rearranges them and then links them back up. So we have our special case for the head, which means if our head is null or our head's number is greater than our eventual current when we actually go to sort it, we set the head as after our current, and then we set our current as a new head since it's the new beginning. Because it's going to be in order, so it'll be lowest first and higher last. So this just sets it so that, hey, if our first one is actually going to be higher, smack that out of being the head and make the one that's smaller than it the new head because it's not the head anymore. And then down here we just have everything else, and we enter a while loop saying that as long as the next number isn't null and our next number is greater than our current, we just keep going and keep adding on to the next. Um, and then now we have insertion sort. So we initialize our sorted linked list, and we use a while loop to go through each number in our linked list, and so we have no more numbers left. Um, and so we mend the connections for our current. Uh, and down here, we insert our current into our new sorted linked list, which uses this one right here. So this is when these will actually become like the current. How I said like later on, that's what it means. And then we update our current to move on. And so now let's go down here and show it off. We have all these numbers. We're inserting them out of order. And then we're going to display. Hold on. We're going to display them out of order. And then we're going to use insertion sort and then display them in order. So let's start without debugging. Displaying our nodes now, so we have 1, 7, 2, 9, blah, 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 all in a nasty order. And then we press any key to continue. And after using insertion sort, we are now in order. Um, and so now we will just switch out what's being commented out so that we can look at our merge sort and see that it works instead. So now let's go up here to our merge sort. Merge sort is a little more confusing because we have to split it into two halves and then merge them back together. Uh, it's magical how this works. So first we have our sorted merge, which will take our two halves that we'll make later on. And this will just be a base case for our two halves, and say if they're empty, and then just return the other one. And then this says pick one of the halves and move through it, which is our if statement here. So it just picks one and goes for it. And then the else is just say when the other half is done, just move on to the next half, and then return our results. And then so this is the function that actually splits our linked lists into a front and back half to sort through, and then to later merge together. So this example that I looked at to learn how to do this uses the fast slow pointer strategy. And what that means is down here, we advance fast 2 nodes and slow 1 node so that our slow node will eventually become our midpoint to cut through. And then once, so we enter the while loop and say while fast does not equal null, we move through, and same for down here, if fast does not equal null, and then we move fast again and slow once. So as soon as fast becomes null, then we come here and say, okay, so our back ref will be slow, our slow value, and our front ref becomes what our or everything past what our slow was. And now we come down here, and this will be the one that actually uses the 2 other functions to sort through our list and change our order. So we come down here and we grab an A, a B to use for our 2 halves. And so then we come here and we say base case for an empty or short node. So if there is no head or it's only 1 in length, then just return. And now we use front back split to split our linked list into 2. And then we come down here, we merge sort both halves of it, and then use sorted merge to merge the 2 of them back together. And so now we come down here and we do the same thing. We get the same numbers, and we display them out so that we can see that they're out of order. Then we come down here and we use merge sort and then display that. So let's build this out and debug this. So we have all of our stuff out of order, and then we have all of our stuff in order. So that would be both merge sort and insertion sort that are able to put all of my stuff in order. Thank you.